Hey team, in this video we're going over the properties of kites and trapezoids. Let's get to it. Let's start with the kites. And so, we have three properties that make a kite. The first one, we have two disjoint pairs of consecutive sides that are congruent. Okay, we'll explain what that means in a second. So let's get it down on the paper. Two disjoint pairs of consecutive sides that are congruent. Okay. The second property, diagonals are perpendicular. And the third property, the longer diagonal bisects its angles and the shorter diagonal. So there we have it. We have the three properties. So here we have the three properties of kites. Let's go ahead and look at an example. So here's our drawing of a kite. Let's go ahead and name this kite Mark. And the reason we had to say that it's two disjoint pairs of consecutive sides that are congruent, well, here we have MA and MK. They're clearly not equal. They're different lengths, and so we couldn't just say consecutive sides are congruent. We have to distinguish it and say, hey, we have disjoint pairs. So the top two lines are a pair, they are congruent, and these bottom two lines are a pair, those are congruent. So we have two disjoint pairs, consecutive pairs that are congruent. That makes a kite. So let's go ahead and look at an example. Let's say MA would equal 5x plus 8. And over here on the right, we'd have AR would be equal to 3x plus 24. And since we have consecutive pairs are congruent, or disjoint pairs are congruent, well, hey, here's one of our pairs. And so to set this up, we'd say 5x plus 8 is equal to 3x plus 24. So here, now we have an equation. Let's algebra from here, so I'll subtract 8 on both sides of the equal sign, leaving us with 5x on the left, and 3x plus 16 on the right. Subtract 3x on both sides, so we get our variable on one side. Our goal is always isolate the variable, leaving us with 2x equaling 16, and divide 2 on both sides, x will equal 8. Alright, let's look at one more example for a kite. So let's say here is our lovely kite, and let's name this one. Here, let's draw our diagonals in it and then we'll name it. Here's one diagonal and here is the other diagonal. Okay. And let's name this one Marie. Mark and Marie. There we go. Alright, and so notice our longer diagonal has they're perpendicular to begin with, so that's a good hint. And it looks like this longer diagonal did bisect this shorter diagonal right here. Yeah, my line's not perfect, but that's what it would be if your drawing was precise. And so let's look at an example of the angles. Let's say right here, angle AER is 22 degrees. We have to find two things. We have to find angle 1 right here, and angle 2 right down here. Well, in order to do that, we have to use this property, diagonals are perpendicular, and perpendicular lines cross at 90 degrees. So right away, you know, angle 1, by that property, hey, angle 1's going to be 90 degrees. And so the third property, we said the longer diagonal bisects its angles and the shorter diagonal. Therefore, if this is 22 degrees right up here, well, hey, it's going to be 22 degrees right here as well. And so if that's 22 degrees, right here you have 90 degrees. Well, let's see, 90 plus 22, hey, that's 112. And see how we form a triangle? Technically we have 4 triangles right here. And in every triangle, you have 180 degrees. So 180 degrees minus 112, you're at 68. So angle 2 is going to be 68 degrees. Alright, let's go ahead and look at the trapezoids. In a trapezoid, we have one property that really matters. So all of these shapes are quadrilaterals, but this quadrilateral, the trapezoid, only has one pair of parallel sides. Now, some people define it differently, and some books define it differently, where they would say at least one pair of parallel sides. Well, if that's the case, if they change this to saying at least one pair of parallel sides, that means your parallelogram, your rhombus, your rectangle, your square, all those would be trapezoids. Well, saying it only has one pair means this is in a separate category, and it'd be off by itself. And so if you have a table, your quadrilaterals, your parallelogram here, your rectangle, your rhombus, your square, all are by itself, and over here we have our trapezoid set off in a different tree under our quadrilateral family. Because these would have two sets of parallel sides, this one would be defined as only one set, not at least one set. And so let's go ahead and look at a trapezoid. So here's the trapezoid. Let's name this one Trap. So we have T-R-A-P. And let's see, so our bases here would be our parallel sides right here, and you can call those bases. Let's say we have up here in the top right corner, so angle A would be 15x plus 9. And in the bottom right corner, we'd have just 51 degrees. Alright, well, looks like we have a transversal line with two parallel lines, so if I took away this RT side RT, we just have two parallel lines and a transversal, and it looks like we have two angles that are the same side interior angles. And if I know anything about same side interior angles, they add up to 180 degrees. And therefore, when we're trying to solve for x in this problem, we're going to have 15x plus 9 plus 51 would all equal 180 degrees. And that's the setup. And so now combine any like terms that we have, so 9 and 51 would become 60. And we still have 15x here. And that'd be equal to 180. And so, let's see, a two-step equation now, subtract 60 on both sides. So 15x equals 120. And divide 15 on both sides, x is going to equal 8. Alright, let's take a look at the next trapezoid, isosceles trapezoids. Isosceles trapezoids, we have three different properties. Now, any isosceles trapezoid is in general a trapezoid, and so we're already assuming it has only one pair of parallel sides, and we can call those the bases, and it has these additional properties. And so, the legs are congruent by definition. And so, if we have the parallel sides being the bases, the other two sides, we'd call those the legs. The second property, lower base angles are congruent, and the upper base angles are congruent. And if it's turned on its side, then you'd say left or right or anything like that. And the third property, diagonals are congruent. So those are the three additional properties that would create an isosceles trapezoid. Let's go ahead and make a picture. So here would be our picture. We have our parallel bases. And then these sides would be called the legs, and they would be the same length. They'd be congruent. So let's go ahead and call this one Zoid. Z-O-I-D. And on the left, let's say ZO would be the expression 2x plus 24. And on the right side, ID would be the expression 5x plus 18. And so looking at this first property, the legs are congruent by definition. Well, hey, that means these would be the same exact length. So if you ever have a problem like this where you're given the two legs, the expressions on each leg, set those equal to each other. So we have 2x plus 24 equals 5x plus 18. And then let's see, you have some options to set this problem up. I'll go ahead and subtract 18 on both sides, leaving us with 2x plus 6 equals 5x. Then subtract 2x on both sides. Again, our goal is to isolate the variable, leaving us with 6 equals 3x, and divide 3 on both sides, x is going to equal 2. Now let's look at a second example. Let's say we had, copy this picture, let's say we had the angles given to us. So up here we had 4x here. Let's name this first. Let's say it's Berg. So we have Zoidberg. Alright. Zoidberg, it's a trap. So we have 4x minus 9. And up here in this top right corner, we have 140 degrees. And so here we have our parallel sides, here and here. And we have the upper, something we define as, or refer to as the upper base angles. And they're congruent. So we'd say we have 4x minus 9 is equal to 140 degrees. And so adding 9 over, we'd have 149 equals 4x. And so when you divide 4 on both sides, we would get 37 and a quarter, or 37 1/4, 37 1/4. However you want to write it would work out as the answer. And let's do a third example. Let's look at the diagonals. So let's get our isosceles trapezoid here one more time. This time let's draw the diagonals in. And then this one, and this time we'll call this one Clark. So C-L-A-R-K. So here I'm going to say CK is going to be 14, and LR will be the expression, equal to the expression of 2x minus 8. So here, we are using the third property, that diagonals are congruent. So for setting this up, well, CK is 14, LR is 2x minus 8. They are going to equal each other. And so, add 8 to both sides. 2x equals 22. Divide 2 on both sides. X would equal 11, and that would be the value. And so we did one example of each. The diagonals, the consecutive angles, the upper bases being congruent, and our legs being congruent. And so, there we have it, our isosceles trapezoid, and kites.